Hello, fourth grade teachers. Today we're going to look at Unit 1, Making Relevant Connections with Place Value Understanding, Addition and Subtraction of Whole Numbers. The purpose of this video is to provide an overview of the standards, suggested pacing, and sample some instructional strategies. In this portion of the video, we're going to review the AKS, which are our academic knowledge and skills, and the indicators of achievement, or IOAs, for Unit 1. The AKS is the overarching knowledge and skills that students are expected to master. The IOAs are the learning objectives that allow students to demonstrate mastery of the AKS. The AKS and IOAs may not be taught in their entirety the first time they appear on the instructional calendar. Some AKS and IOAs will appear multiple times throughout the year. In Chapter 2 of the video, we will look to see how the AKS and IOAs in this unit are paced in more detail. Welcome to fourth grade Unit 1, Making Relevant Connections with Place Value Understanding, Addition and Subtraction of Whole Numbers. Unit 1 has 3 AKS. Under the AKS, you will find the indicators of achievement, or the IOAs. You will be teaching all 4 of the IOAs for AKS 4MA A1. For AKS 4MA A2, you will only be teaching IOA 2A and IOA 2E, because our focus is addition and subtraction only for this AKS in Unit 1. In Quarter 2, you will be teaching this AKS again with a focus on multiplication and division. For AKS 4MA D6, this unit will briefly introduce IOA 6B. This AKS and IOA will reoccur in multiple units. Notice the extension IOA 6E. Extension IOAs support the differentiated needs for your students. As you can see, the word extension is bolded and in parentheses to notify that these are extensions and they are specific to Gwinnett County. Please note, you will not find resources from the state of Georgia for these IOAs. You will also see that we have provided you with the state coding at the end of the IOAs. So if you're looking for resources on the Georgia DOE website, you will be able to find the IOA that is related to the GCPS IOA. In this unit, students will read and write multi-digit numbers to the hundred thousands place using base 10 numerals and expanded form. Students will show that a digit in one place has a value 10 times greater than what it represents to the place to its right. Using place value reasoning, students will compare and order multi-digit numbers, as well as round multi-digit numbers. Students will solve addition and subtraction problems within the hundred thousands place fluently. We are going to discuss IOA 1A. Students read and write multi-digit whole numbers to the hundred thousands place using base 10 numerals and expanded form. Students need to show flexibility with decomposing numbers in various ways and explain how the different place values are related. For example, 510,114 can be decomposed into 500,000 plus 10,000 plus 100 plus 10 plus 4, and it could be 510,000 plus 100 plus 10 plus 4. Students show their place value understanding by creating equivalent forms of numbers. This understanding helps them understand decomposing to regroup when subtracting and composing to regroup when adding. This deeper understanding of place value helps them form inventive strategies for adding and subtracting. For IOA 1B, students use numerical reasoning to represent and explain, using concrete materials, the relationship among the numbers 1, 10, 100, and 1,000. They will extend the pattern to the 100,000s place and recognize the relationship of the same digit or same digits located in different places in a whole number. Two important ideas should be extended to larger numbers. First, a 10 in any position makes a single group in the position to the left. A digit in one place has a value 10 times greater than what it represents in the place to its right. And extend this understanding to determine the value of a digit when it is shifted to the left or to the right. Second, oral and written patterns for numbers in 3 digits are duplicated for every 3 digits to the left. Students use place value reasoning to represent, this is for IOA 1C. Students use place value reasoning to represent, compare, and order multi-digit numbers less than 1 million through the 100,000s place. This includes ordering up to 5 whole numbers. Students use symbols to record the results of the comparison. Students are developing a solid understanding of building and comparing numbers based on their magnitude. And for IOA 1D, students will explore rounding within multiple authentic situations. Students round whole numbers to the 1,000s, 10,000s, and 100,000s place and locate numbers on a number line to determine the nearest multiples of thousands, 10,000s, or 100,000s. This is the focus for 4th grade. Students are aware that rounded numbers are approximate and not exact, and exact answers can be rounded to different place values. Rounding is useful for estimation, and students will need to be able to select a compatible number that will make a problem easier to compute mentally. Students will have to be taught the convention that if a number being rounded has a 5 in that place being considered, it will round up. Using a number line is a powerful tool to use when rounding. Students need to have an understanding of rounding as one of several strategies to make estimates and determine the reasonableness of answers. Once they have developed a conceptual understanding of rounding and use this to generalize a procedural understanding, they need to use number sense to determine how best to round given the context of a situation. Providing context helps to support the students in how they should round a number, not because of a set of rules, but instead for what the problem is asking. Now we're moving down to AKS 4MA A2. I'm sorry, 4MA, yes, A2. But we're going to be looking at the IOA 2A. For IOA 2A, students fluently add and subtract multi-digit whole numbers within 10,000 and 100,000 to solve relevant mathematical problems using efficient, accurate, and flexible procedures based on their knowledge of place value and properties of operations. Students use an efficient strategy, one that can be carried out with ease with a minimal number of steps. Keeping track of subproblems and making use of intermediate results to solve the problem precisely. Students think about a problem in more than one way and adapt or adjust their thinking. Students are given the choice of which procedure or strategy they use when adding and subtracting multi-digit numbers, and they use part-whole reasoning and estimation strategies to engage with larger numbers and make sense of problems. For 2E, even though this IOA mentions all 4 operations, during this unit, the focus is only on multi-step problems for addition and subtraction. Students use the addition and subtraction to solve authentic, multi-step mathematical problems. Students represent and model problems using equations and diagrams with the variable for the unknown quantity. Students understand that a symbol or letter can replace an unknown quantity in an equation. Students use mental computation to determine if an answer is reasonable, as well as estimation strategies, such as using compatible numbers or rounding. Next, we will discuss 6B and 6E, which is an AKS 4MAD6. For IOA 6B, fourth grade students engage in the statistical problem-solving process to make sense of number and quantity through graphical displays of data relevant to everyday life. Students will generate and make sense of statistical investigative questions based on things they notice and wonder about an everyday situation. Based on the statistical investigative question, students should create a plan that determines the appropriate population to survey and how to collect that data. Students determine the difference between the representations for categorical data and numerical data presented. Representations for data should include bar graphs, pictographs, and dot plots or line plots. Students record observations they notice about the shape of the distribution using informal language such as spread out or grouped. In Unit 1, we will introduce 6B in a lesson that reviews the different ways to graphically display data. However, 6B will be revisited throughout the school year. In Chapter 2, we will be discussing our Unit 1 pacing. Our pacing guides are closely aligned with the state pacing to ensure we are following the expectations from the state. The pacing guide is an example intended to model how instruction of the AKS and IOAs in each unit may be facilitated. But teachers should design pacing to be responsive to the learning needs of their students. So now I'm going to come over to Ecom and show you how to navigate to pacing. The first thing you will do is under Instructional Resources, click on your grade level. Next, you're going to choose the Math button under Instructional Resources. Then you're going to scroll down and click on the link for Unit 1. Scroll down again until you find the Pacing Guide button. At the top of the pacing guide, we have shown you the suggested length. You can see that Unit 1, it is suggested to last around 4.5 weeks. The suggested sequence is located on the left-hand side of your pacing guide. The left column provides the learning progression for the AKS and the IOAs, showing whether it is concrete, representational, or abstract. You can see on this first day, it is concrete and representational. The bulleted list states the specific learning objectives within the IOAs, as well as suggested manipulatives. So you can see the learning objective for this day is to read and write multi-digit whole numbers to the 100,000th place, and we suggest base 10 blocks and a place value chart. Over on the right-hand side of the pacing guide are the resources for each day. The resources are going to include traditional lesson plans, task-based lesson plans, formative assessments, small group instructional moves, student tasks, and any additional resources that are aligned to the learning targets for that day. Also embedded in the pacing guide is suggested resources to use from our textbook adoption, Georgia Reveal. Georgia Reveal is intended to be used as a supplemental resource, not your primary resource. You will find Georgia Reveal adapted lessons aligned to the intended learning objectives, as well as other resources on the pacing guide. These are just a few of the Georgia Reveal resources available. You can go to your employee portal to access all of the Georgia Reveal resources and see the plethora of resources available for the needs of your students. It is suggested to The suggested number of days for IOA 1A and 1B is 6 days. As you can see, we offer many resources. I'm going to scroll down to this particular resource page here. You can see there's many resources provided, but please select the best ones to meet the specific needs of your students. Now I'd like to scroll down to a day that has, this day actually also has a Georgia DOE task. So let's just stay on this day. You can see that we also have provided links to Georgia DOE tasks. When you open these links, you're going to open a document with multiple pages and resources, but the link that we provided will land on the first page of the task that corresponds with the page number noted on the pacing guide. So right here, for instance, this particular task is going to be on page 1 when you click on the link. Let me scroll to a different one so you can see another option. For this Georgia DOE task, when you click on it, you will be landing on page 4. Similar to your GCPS resources, this is a living document that could be updated by the state. Scrolling on down, we'll move on to IOAs 1C and 1D. The suggested pacing for IOA 1C and 1D is 6 days. I also want to point out that there are a few days on your pacing guide that notes that teacher creates the lesson based on the day's learning goals. This is a day that you or your team will create lessons aligned to your specific student learning goals. Now we're moving down to a new AKS. So also in Unit 1, you will be teaching part of for MAA2. You will only be spending time on the addition and subtraction portion of this AKS. We have suggested 10 days for IOA 2A. We've also clustered 2E on 2 days to include multi-step problems with addition and subtraction only. 6B has also been clustered with 2A and 2E on one of the days. And let's go ahead and look at the end of our pacing guide to see examples of that. So you have 2A only. And then when you get down here, you can see that we've clustered 2E with 2A. And then on this day, we've also clustered 6B with 2A and 2E. And note here the learning objectives. We can see from 2A, we're adding and subtracting multi-digit numbers fluently. From 2E, we're solving multi-step problems. And for 6B, we're also interpreting data on a graphical display. And lastly, at the end of each unit, we have linked a suggested unit assessment. This portion of the video will highlight some instructional strategies that will be utilized in this unit. Please refer to the Analyzing the Standards, or sometimes called the ATS, for guidance on additional instructional strategies for each IOA.
Today, we're going to use our place value reasoning to represent and compare multi-digit numbers. We will use a place value chart and place value disks. We'll also record the comparison using the symbols greater than, less than, or equal to. Using a place value chart, like the one you see here, will help us remember the names for each place, and it will help us see the value of each digit in the multi-digit number. Let's take a look at this problem. Samuel and Noel were keeping track of the points they collected on their favorite video game. Samuel has collected 12,422 points, and Noel has collected 12,432 points. Compare 12,422 and 12,432 by building the number with place value disks. Record the results of the comparison using the symbols less than, greater than, or equal to. Who has collected the most points? In this problem, I noticed that Samuel and Noel each collected points from a video game. However, the number of points they collected was different. The problem is asking us to show these numbers in a place value chart by building them with place value disks. And then we're going to use that to help us compare the numbers and record the comparison. So let's begin by building these numbers. Let's look at Samuel's number of points. Samuel collected 12,422 points. I know that the number 12,422 has 12,000 in the thousands period. So I'm going to build 12,000 with the place value disks. So there's one 10,000 and there are two 1,000s. All right, and the rest of this multi-digit number is 422. So there are 4 hundreds, or 400, two tens, or 20, and two ones. All right, so I can see the value of each digit in this number, 12,422. Now let's build Noel's number. Noel had 12,432. So again, there are 12,000 in the thousands period. Try another pen. 12,000, so that would be 1 10,000 and two 1,000s. Okay, and then he had 432 in the ones place. Or I'm sorry, in the ones period, I should say. So that is 400, 400, three tens for 30, and two ones. And again, I can see the value of each digit in the multi-digit number 12,432. So now, to compare these numbers, I'm going to begin in the greatest place value, the 10,000s. And I notice they both have one 10,000 or 10,000s. So they're equal in that place. So I'm going to move to the next greatest place value, which is the 1,000s place. And again, I notice they both have the same value of 2,000. So let's move to the next greatest place value. Each of these numbers has a value of 400. So again, they are equal so far. Now, as I move to the tens place, I notice something different. I notice that Noel's number has 3 tens, where Samuel's number of points has 2 tens. Because I know that 30 is greater than 20, this shows and tells me that Noel had a greater number of video game points collected than Samuel. All right, I can write a comparison statement about these two numbers. So I wrote 2 comparison statements. I can see from this place value chart that 12,422, which is Samuel's points, is less than 12,432. I could also say that 12,432, which is Noel's points, is greater than 12,422. So this chart shows me, as I compare, that Noel had a greater number of points than Samuel. Noel collected the most points. Now, as students begin to develop a conceptual understanding of comparing numbers using place value reasoning, they may navigate more towards more representational pictorial models. So they may begin drawing place value discs on a place value chart like this. And so you might see them doing the same work, but without the place value disc, the actual concrete materials. So it's the same result, it's just pictorial. Now, students may also, as they move away from the place value chart, they may write numbers more abstractly. So they may actually expand these two numbers and compare them by place value in that manner. So for example, we could expand each of these numbers. So we could expand 12,422 as 10,000 plus 2,000 plus 400 plus 20 plus 2. And then we could expand 12,432 by its place value in the same way. And I can see from this expanded form that each of these numbers has the same value of 10,000s. It has the same value of thousands, and it has an equal number or value of hundreds. But again, you can see in the tens place, Noel's number is greater than Samuel's number with the 20 or 2 tens. So a place value chart and place value discs and expanded form are all great ways to help students compare numbers. Today, we're going to explore rounding a multi-digit number using a number line. Let's take a look at this problem. Gwinnett County Public Schools had 177,401 students in the 2020-2021 school year. Round the number of students to the 10,000s place. Okay, well, something I notice in this problem is that there are 177,401 students that were in Gwinnett County Public Schools. And I built that number here on the place value chart. So 177,401. And the problem is asking us to round the number of students to the 10,000s place. All right, so I'm using this place value chart to help me visualize and see kind of what this number looks like. And I'm wondering what the value of each digit is. So I'm focusing now on this 10,000s place because I need to round the nearest 10,000. So in the number 177,401, I know there are 7 10,000s or 70,000. So thinking about what we would call benchmark numbers, I know that if I count back 1 and I count back 400 and I count back 7,000 more, I will land at 170,000 on a number line. So 170,000 would be one of our benchmark numbers. 170,000 is less than 177,401, but it's the nearest or closest 10,000 counting back. Right? If I count forward and count on from 177,401, I will count up to the next closest 10,000, which has a value of 180,000. And this makes sense because I know 177,401 is greater than 170,000, but less than 180,000. It's going to fall in between these two benchmark numbers. Now, in order to help me determine which of these numbers is closest to the number of students in Gwinnett County Public Schools, I'm going to also think about what the midpoint of this number line is, because that midpoint will help me determine which benchmark number is closest to 177,401. I know that there are 10,000 in between 170,000 and 180,000. Okay. I'm going to think about what half of 10,000 is. I know half of 10,000 is 5,000. I'm going to mark that in the center here because 175,000 would be the midpoint between 170,000 and 180,000. Okay. If your students are struggling with finding that midpoint, they could find each 1,000 interval or increment in between 170 and 180,000. So they could count each 1,000 if they needed to. So this first tick mark could be 171,000, 172,000, and so on, where if they found each of the 1,000s, there's 10 1,000s and a 10,000, they could actually number those to find the midpoint. All right. So that is also another way you could number this number line. Okay. So thinking about this midpoint, I can now locate where 177,401 would be on this number line, right? So I know that this number is greater than 175,000. It's going to be somewhere in here, okay? So I can note that on my number line. And I can see that 177,400 is closer to 180,000. The distance back to 170,000 is greater, so that would not be the closest 10,000. So to answer the question, round the number of students to the nearest 10,000s place, we would round 177,401 to 180,000. So there are about 180,000 students. Today we're going to solve a subtraction word problem using place value discs, a place value chart, and expanded form. Let's take a look at this problem and see what we notice and what we need to figure out. At the start of the football game, 3,546 people were in the stadium. At halftime, 928 people left the game. How many people stayed at the game after halftime? So I notice in this problem that there are 3,546 people in the stadium. The problem also tells me that 928 people left the game at halftime.
And I'm trying to figure out how many people stayed at the game after halftime. So I'm really trying to figure out how many people were left after the 928 people left the game at halftime. So I'm going to solve a subtraction problem. And I wrote a subtraction problem here. And I'm going to figure out what 3,546 people who were in the stadium subtract 928 people who left the game at halftime. I'm going to see how many people were remaining after halftime. So how many people were at the game after halftime? I represented P as the people left after halftime, right? So we are going to use these concrete place value discs today to help us subtract or remove 928 from 3,546, all right? All right, so I'm going to begin in the ones place in case I need to do any regrouping. So I'm going to subtract 8 ones. However, when I look at the ones, I notice there are only 6. I do not have 8 ones to take away. So I'm going to regroup a 10. I know that 110 is equal to or the same as 10 ones. So I'm going to take this 10 and I'm going to regroup it for 10 ones. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so now you see there are 16 ones. So I had 4 10s and 6 ones, but now I have 3 10s and 16 ones. The value is the same. I just regrouped a 10 as 10 ones. Now I can subtract 8 ones. So 1, 2, 3, 4, 5, 6, 7, 8, right? And I'm going to jot how many ones are left here. And I see that there are 8 ones left right now. So I'm going to write that right here. 8 ones. All right, so let's go ahead and subtract the 2 10s. I'm going to take 2 10s from the tens place. There are now 3 10s or 30. Right, so 30 subtract 2 10s would leave me with 1 10. So I will have 1 10 remaining. So there's 10. Okay, so first I subtracted 8, but I regrouped a 10 for 10 ones in order to do that. And then I subtracted 2 10s. All right, now we're going to subtract the 900s. Again, I notice I have only 500s. There are not 900s to remove. So I will need to regroup one of these thousands for 10 hundreds. I know that 1,000 is equal to or the same as 10 of these hundreds. So I'm going to regroup this 1,000 as 10 hundreds. 1, 2, 3, 4, 5, 6, 7, 9, and then there's 10 or 1,000. All right, so now we have 1,500s or 1,500 in the hundreds place. I'm going to subtract that 900. So 1, 2, 300, 400, 500, 600, 700, 800, and 900. All right, so now I see that there are 600 left in this area. So I'm going to write 600 to help me remember that. All right, so I wasn't subtracting any thousands in this problem. So I'm just going to write 2,000 here, since I just have that left as well. So after subtracting 928, we're going to compose or add together these differences here to get our final answer. So 2,000 plus 600 plus 10 plus 8 would give me a solution of 2,618. Right? So that tells me that 2,618 people stayed at the game after halftime. So when 928 people left at halftime, 2,600 people were left. All right. Now, we solved this problem with a place value chart and concrete place value discs. As students begin to develop a conceptual understanding of subtraction with regrouping, they will begin to move to something more representational or even abstract. Right? So students may begin doing some problem solving like this. They may actually draw place value discs and move to this representational pictorial model on a place value chart. These place value discs that are drawn are the same representation as using the actual concrete discs. Okay, so let's solve this problem with a pictorial model now and with expanded form. All right, so with expanded form, we basically expanded out each number by its place value. So 3,546 was expanded as 3,000 and 500 and 40 and 6. And then we're removing or subtracting the 928, all right? Okay, so let's begin in the ones, like we did the last time. We're going to subtract 8 ones. But as we already know, we only have 6 ones. There are not 8 ones to subtract. So I am going to regroup a 10 as 10 ones. I know that 10 is equal to or the same as 10 ones. I'm going to cross out a 10 here, okay? And I'm going to draw, and I'm just going to note it with an arrow. I'm going to draw an arrow over here to the ones because I'm actually regrouping that 10 as 10 ones. All right, so there are the 10 ones. Okay, so now there are 16 ones and 3 10s, which is equal to 4 10s and 6 ones. All right, so now I'm able to subtract the 8 ones. So let's subtract those. 1, 2, 3, 4, 5, 6, 7, 8. All right, and we can see that there are 1, 2, 3, 4, 5, 6, 7, 8 ones remaining. So I'm going to write 8 here, but before I do that, I'm going to show that same subtraction right in this expanded area. Okay, so I'm going to regroup a 10, just like I did here. There will be 30 left instead of 40. So we're taking that 10 and we're going to place it with the 6. And that will give us 16. right? So now, again, we have actually 16, subtract 8, which is 8, all right? Okay, so we had to regroup a 10 as 10 ones in order to subtract that 8. Okay, next, we're going to subtract a 20. Similar to the last problem, we're just removing two 10s. So 30 subtract 20 is, write this in blue, 10. Here we go. So we have 10 there. All right. And then last, we are subtracting 900. All right. And we found out with the concrete model that we only have 500 rather than 900. We need 900 there to subtract. So we're going to regroup 1,000. Okay. So I'm going to take that 1,000, I'm going to cross that 1,000 out because I'm going to move it over here. I'm going to draw an arrow. I'm going to move that 1,000 to the hundreds place. And I'm going to draw 10 hundreds. All right, so 10 hundreds is the same as or equal to 1,000. Now, I have in the hundreds place here, there are 15 hundreds or 1,500. I want to show that same regrouping down here. So we're going to take 1,000. So there will be 2,000 here. And we're going to put that 1,000 with this 500. So I've just regrouped 1,000 to 500. Okay. So you see that 1,500 would give us that 1,500 or 1,500. When we subtract the 900, so 100, 200, 300, 400, 500, 600, 700, 800, 900, there are 600 remaining in the hundreds place. Okay, and we are not subtracting any thousands, so we're going to bring that 2,000 down here, since that is left as well in our place value chart. And so looking at the chart or the expanded form, we can see that there are 2,618 people left. So 2,618 people remaining after halftime in the game. All right, so today we solved the subtraction problem with regrouping using a hundreds chart, concrete place value discs, a representational drawing, and
Today, we're going to explore an invented strategy called Think Addition. An invented strategy is any strategy other than the standard algorithm. It's based on place value, properties of operations, and or the relationship between addition and subtraction. With invented strategies, students generally do not use concrete materials or count by ones. Invented strategies help students be more efficient and understand the math successfully. They're mathematically valid and they're generalizable. Invented strategies also provide a range of flexible options for students rather than one right way. They're student-centered and they focus on number sense and mental math. Not all students invent their own strategies. Strategies invented by students are shared, explored, and tried by others, though. Today, we're going to highlight the Think Addition strategy. Think Addition is helpful
when subtraction of multi-digit numbers requires regrouping more than one time or multiple times. Let's look at a subtraction problem that students might encounter in a scenario. All right, we have the problem 86,003 subtract 68,929. With think addition, students are starting with the subtrahend, the number that's less, 68,929, and they're counting on to the minuend up here, the greater number, 86,003. By counting from this subtrahend, 68,929, up to 86,003, students are able to figure out the difference between those two numbers. So we're going to start with 68,929. And we're going to think through this problem as a student might. So a student might add 1 to this number to arrive at a friendly 10. So we would have 68,930. Okay, from there, a student might add on 70, because 70 would get them to a really friendly number of 69,000. And from 69,000, a student could then add 1,000. And that would help them add to 70,000. Now, 70,000 would be a very efficient number to add to. So a student could look at 70,000 and get to 86,000 by just adding on 16,000 more. So they would find 86,000. And now look, we just need to add 3 more to 86,000. To arrive at 86,003. Now, by adding on these values, when we compose these values back together, we will find the difference in this subtraction problem. We'll find our answer. All right, so we can add 16,000 plus 1,000, which is 17,000. And we can add together 70 plus 3 plus 1, which would be 74. And our solution, or our difference of 86,003 subtract 68,929, would be 17,074. So students who are efficient with counting on using place value strategies will sometimes choose a think addition strategy rather than subtracting with regrouping. To access more samples of addition and subtraction strategies, please see the Analyzing the Standards